In the grand, sprawling tapestry of the cosmos, our universe is a masterpiece of cosmic threads, woven from countless galaxies, stars, and nebulae. From our vantage point on Earth, we look up and see a sky brimming with light, a testament to the sheer density of matter that fills the void. We've come to understand that galaxies are not scattered randomly but are organized into vast structures called filaments, like intricate threads of a cosmic web, separated by enormous, relatively empty regions known as voids. This structure is a fundamental prediction of our models of the universe's evolution, a natural consequence of gravity pulling matter together over billions of years. But what if we found a region so profoundly empty, so staggeringly vast, that it defies our understanding of normal? What if we stumbled upon a hole in the universe itself? This isn't a hypothetical question. In 1981, astronomers Robert Kirshner, Augustus Onward Jr., Paul Schechter, and Stephen Schechtman were conducting a survey of galaxies in a patch of sky in the constellation Boötes. As they mapped the positions and distances of galaxies, they began to notice something deeply unsettling. In a specific direction, beyond a certain distance, the galaxies just stopped. Where they expected to find thousands of luminous island universes, they found an unnerving, profound nothingness. They had discovered a region of space so devoid of matter that it would come to be known as the Great Void, or more formally, the Boötes Void. This discovery presented a chilling puzzle, a gaping anomaly in our map of the cosmos that challenges our most fundamental theories about its structure and evolution. The scale of the Boötes Void is almost impossible for the human mind to comprehend. It is a colossal, roughly spherical region of space measuring approximately 330 million light-years in diameter. To put that into perspective, our own Milky Way galaxy is about 100,000 light-years across. If you were to place our galaxy at the very center of the Boötes Void, our nearest galactic neighbor, Andromeda, which is 2.5 million light-years away, would still be deep within our own local cosmic neighborhood, a mere stone's throw from home. The edge of the void would be hundreds of millions of light-years further out in every direction. An observer inside the void would look out into a sky of almost perfect, terrifying blackness. The sheer emptiness is what makes it so baffling. Based on the average density of galaxies in the observable universe, a region of this size should contain tens of thousands of galaxies. Yet, initial surveys found only a handful. It was as if someone had taken a cosmic eraser and wiped a massive section of the universe clean. Later, more sensitive surveys managed to identify around 60 galaxies scattered within this immense volume, but this is still a tiny fraction of what should be there. These lonely galaxies are arranged in a strange, tube-like structure running through the center of the void, isolated beacons in an ocean of darkness. The space between them is so vast that if you were on a planet in one of these galaxies, you might not have known other galaxies even existed until the 1960s, when our technology became advanced enough to detect them. This profound emptiness presents a significant challenge to our standard model of cosmology. The model explains the formation of cosmic structures through the slow, steady pull of gravity over billions of years. After the Big Bang, tiny quantum fluctuations in the early universe were stretched out, creating regions of slightly higher and lower density. Over eons, gravity amplified these differences. Denser regions pulled in more and more matter, eventually collapsing to form the stars, galaxies, and galaxy clusters we see today. The less dense regions, in turn, became emptier as their matter was siphoned away, forming the cosmic voids. This process works well to explain the existence of voids in general. They are a predicted and observed feature of the cosmic web. However, the Boötes Void is an outlier. It is simply too large and too empty to be easily explained by this model. Computer simulations of the universe's evolution struggle to produce a void of this magnitude naturally. For such a vast region to be cleared out by gravity alone would require an immense amount of time, potentially longer than the current age of the universe. It's as if the universe didn't have enough time to create a hole this big through its normal, gradual processes. This discrepancy has led some scientists to question whether our understanding of cosmic evolution is complete, or if some other, more exotic process is at play. When a natural explanation seems insufficient, it's human nature to consider unnatural ones. This is where the Boötes Void transitions from a mere astronomical curiosity into the realm of speculative, and frankly, terrifying, science fiction. One of the most intriguing and unsettling hypotheses for the void's existence involves the concept of a Kardashev Type 3 civilization. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, is a method of measuring a civilization's level of technological advancement based on the amount of energy it is able to use. A Type 1 civilization can harness all the energy available on its home planet. A Type 2 civilization can harness the entire energy output of its host star. A Type 3 civilization, however, is on a completely different level. It would be a civilization so advanced that it could harness the energy of its entire host galaxy. Imagine a society capable of building Dyson spheres, megastructures that could encapsulate every single star in a galaxy, capturing all of its energy output. Such a civilization would be, for all intents and purposes, masters of their galactic domain. They would possess a level of power and technological capability that is far beyond our current comprehension. But what happens when a Type 3 civilization outgrows its own galaxy? What is the next logical step in its quest for energy and expansion? The chilling hypothesis is that such a civilization might begin to harvest other galaxies. Using technology we can barely dream of, they could systematically move from star to star, and then from galaxy to galaxy, dismantling them for their raw materials and energy. In this scenario, the Boötes void is not a natural formation at all. Instead, it is the result of an ancient, hyper-advanced alien civilization's industrial activities on an unimaginable scale. It is, in effect, a cosmic quarry, or region of space that has been strip-mined of its stars and galaxies. The few galaxies left behind might be those that were deemed unsuitable, or perhaps they are simply the last remnants of a project that was completed or abandoned eons ago. This idea is, of course, purely speculative and rests on a chain of enormous assumptions. There is absolutely no direct evidence to support the existence of a Type 3 civilization, let alone one capable of such cosmic engineering. However, the concept serves as a powerful thought experiment. It forces us to confront the sheer scale of the universe and the possibility of intelligences far older and more advanced than our own. If such a civilization did exist, would we even be able to recognize its activities? Their technology might be indistinguishable from magic, or worse, from natural phenomena. The emptiness of the Boötes void could be the most profound evidence of alien life we have ever encountered, the silent, dark testament to a presence so powerful it can literally erase sections of the cosmos. Of course, the scientific community overwhelmingly favors a natural explanation, even if the details are still being worked out. One plausible idea is that the Boötes void is not a single, monolithic void, but rather the result of several smaller voids merging over time. Just as bubbles in foam can coalesce to form larger bubbles, smaller voids in the cosmic web could have merged to create the supervoid we observe today. This void merger model could potentially explain the void's immense size without requiring more time than the universe has had to exist. Another possibility is that our current understanding of gravity or dark energy, the mysterious force driving the accelerated expansion of the universe, might be incomplete. Perhaps there are aspects of these fundamental forces that operate differently on very large scales, leading to the formation of such extreme structures. Ultimately, the Boötes void remains one of the most profound mysteries in modern astronomy. It is a stark reminder that the universe is far stranger and more complex than we can imagine. It could be a perfectly natural, albeit statistically unlikely, feature of the cosmic web, a testament to the random and chaotic processes that shaped our universe. Or, it could be something else entirely. It could be a scar left over from an unknown cosmological event in the early universe, or a window into new physics that we have yet to discover. And, in the farthest reaches of speculation, it could be the silent, terrifying evidence of an intelligence so vast and powerful that its very existence has reshaped the fabric of the cosmos. As we continue to peer deeper into the darkness, we are left with more questions than answers. The Great Void in Boötes challenges our models, fuels our imagination, and underscores how much we still have to learn about the universe we call home. It is a place of profound emptiness that is, paradoxically, full of possibilities. Whether it is a natural anomaly or an artificial construct, its existence forces us to confront the vastness of both the cosmos and our own ignorance within it. Thank you for joining us on this journey into the Great Void. If you find these cosmic mysteries as fascinating as we do, be sure to subscribe to Space Repo for more explorations into the unknown. The universe is full of wonders and terrors, and we are only just beginning to scratch the surface.